Alright, so today I'm going to be going over a MacBook Pro 820-3330 board with no video. It has no video, which means we have to reball the video chip, right? Because the video chip must have been bad because of those cheap lead-free solder balls. So what we got to do is we got to take a heat gun to it and heat it up because that's what's going to fix it, right? Let's go over what's actually wrong with it and why that's full of shit. First things first is I want to show you what my problem is over here. So what I'm going to do is I'm going to plug in a screen, we're going to turn it on, and go from there. So I got my screen here. Just get a DC in board. Got myself a new shirt. Got myself a haircut. I'm ready to kick this board's ass. I really got to fix the lighting in this office. I mean, look at how bad everything looks on camera. Like, my arm is not... Like, you don't see my arm, you just see a big blotch of light here, and my forehead is a blotch of light. I got these really, really cheap T8 LED tubes off of eBay, which are just... It's just the junkiest, bluest, purple crap light. I put this stuff over them, but it's still terrible lighting. I mean, if it looks that bad on camera, I can just imagine what it's doing to my eyes looking at it all the time. Alright, so I'm going to plug in a speaker. So remember, one of the first things we want to do here, is it no video, or is it not? Is it dead in terms of doesn't have a brain, has a PCH issue, has an SPI-ROM issue? So first thing we're going to do is see if it chimes when it turns on. So it chimes when it turns on, but I got nothing on the screen. See, my screen's blank. Now, the second thing you got to do here to make sure you're not being an idiot is see if it's no screen or no backlight. Before I even bother going over the whole no image, no backlight nonsense, the first thing that I like to do is I like to see with my multimeter, which I don't think you could see at this angle. Eventually, I'm going to come up with a video setup so you can see it. For now, you will just have to trust that I'm not bullshitting you. I like to check on the part that actually powers the screen if that's getting 3 volts, because there's no point for me looking for an image if that's not coming in. So I don't have 3 volts over there. So to give you a little bit of an idea about how this board works, and I know a lot of people have been complaining recently, like, you need to make shorter videos. Your channel would be so much more popular if you made shorter videos. Well, yeah, if you want shorter videos, just go to the channel with the guy who just doesn't show you anything and has the camera in the corner and has it going at 5x. I'm confident that he's more than happy to show you these videos. But I want to show you how to actually fix stuff and learn. So if you don't want to learn, and you don't want to figure out how any of this actually works, then you can fuck off to somebody else's channel. But anyway, now that I have this over here, let's show you how this works. So what happens is, when you get LCD power enable over here to this chip, the U9000, it's going to take PP3V3S5, which is a 3.3 volt power line, and it's going to send it over to the LCD on this inductor, and that's going to allow the LCD to work and power on. Also, you have this rail over here. There's 2 different rails. So there's rail for powering the screen, and then there's also a data line that's created for the DDC MUX circuit. So over here you have PP3V3_SO, DDC LCD. If you want to look up what a DDC circuit is, you can simply Google, and it will tell you, because there was once a time when I had no idea what that meant, what that meaned. Oh man, that's just dumb. So let's see if I find what I want. There was DDC monitor display data channel. Collection of protocols for digital communication between a computer display and a graphics adapter that enables the display to communicate its supported display modes to the adapter. So long story short, screen, GPU screen. They have to get along, and it has to know that the screen is connected before it's actually going to turn it on. So you see that that's present, and you see if there's 3 volts there. I don't see 3 volts there, so obviously I have no image. Since I have no image, why the hell am I going to check for a backlight? I'm not going to check for a backlight when this is not even being powered on. So the next thing I'm going to do here, before I start chasing and going, oh my god, I need to heat gun my GPU. I do my repair the way I want. Before I wind up being some kind of crybaby fucktard that just wants to apply any random, wrong, incorrect internet solution to his problem, what I'm going to do over here is actually use my brain. So let's say my GPU is not working. What powers my GPU? That's maybe something that I'm interested in seeing. So let's see. Luckily, these older boards are the ones that actually have the block diagram, which is pretty nice. And I do have to figure out how to make my Open Broadcaster shortcuts and not also screw things up in Adobe. we're going to get... See, now after I hit Control 4 to switch, it's not letting me zoom. Every time I zoom, it just goes back. Fucking Adobe. But if I hit Control 4 again, Control 4 is what I use to switch between regular view and viewing the screen capture. It undoes Adobe. It undoes whatever it did that made it not zoom. Let's see. Key shortcuts, keyboard shortcuts. This is way too much shit to go through right now. And of course, none of them say anything about keyboard shortcuts, which means I'd have to Google, which means I have to figure it out. And that's the thing. I don't want to use my brain to figure out how to use the PDF reader. Like, if I got a limited amount of brain power, I want to use my brain power to fix this. So fuck that. We'll deal with that later. All right. So what do we have here? So where is the GPU? So let's see. The GPU on this board is... Come on. Show me the GPU. Here we go. Whistler PCI Express. U8000. U8000. What powers you? Memory interface. So we have PP1v3 5 GPU SOFB P1v5 PP1v5R1V. That's a mouth load. We have PP1v05 SO GPU reg. And what else? Let's also go to the list of power supplies and see what we have present there. I think I missed it. Crap. Let's go back up. Oh man, I'm looking like an idiot. Okay, so GPU vCore, P1v5 FB, and P1VO GPU. So those are the three that we need, right? So let's check GPU vCore. So let's find out what that's actually properly called. So as you scroll down, you're eventually going to get to a page that lists your power rails. That's test points, and here are power rails for the machine. And we have, let's see, PPVcore GPU, PPVcore underscore GPU. So let's take my board view and go PPVcore underscore GPU. Okay, that's a lot of different points that it shows up there. You see that? See how it shows me all the different points at which I can see PPVcore underscore GPU? So I got all these different caps and all these different places where I can see that. So now let's turn it on again with a screen attached to it, and let's see what I get for GPU vCore. So now this schematic over here says that that's supposed to be, for GPU vCore, it's supposed to be 1 volt. Now when I use my multimeter and I measure that, I get 0.165 volts. I'm also trying to be careful. A lot of the audio quality here is actually me using a lot of hisses in my voice and just extenuating my S's in a way that is not good for a microphone. So I'm going to try to be more careful of that because I know it makes the sound, you sound like crap. And somebody actually recently complained about the audio quality. So we're at 0.147 volts. Is 0.147 volts even remotely close to 1 volt? It's not. So let's see what's responsible for that part of the circuit. So PPVcore underscore G... wrong program. Let's go back to the PDF reader. PPVcore underscore GPU. So over here we see that it goes to the GPU. That's not really what I'm interested in. I'm more so interested in what's actually creating it in the circuit. And it's probably called something else here. Let's try PPVcore underscore SO underscore GFX underscore reg. Let's see if... here we go. So this brings me to U8900, which is the ISL6288 chip. This is responsible for controlling the buck regulator of Q8930 and Q8961, along with Q8930 and Q8931. Yeah, so Q8930 is here twice. Okay. Let's see what this stuff looks like. So U8900, so we're going to go back to my board view over here, and we're going to look for U8900, and Q8930, Q8931, U8900. Let's get that verbose mode crap off. So that is what that looks like, right? So now let's get a little bit of a look under the microscope and get an idea of what it is we're actually looking at. So I'm going to unplug my screen and my fan and the speaker so that makes it a little bit easier to look under the microscope and a little easier to inspect. So when we go over to that part of the board, we get this. Now, does this look like it's supposed to? You know, again, your honest opinion. Do you think this is supposed to look like that? Again, hint. I haven't started screwing with this board yet. Oh, what's that? Oh, what is this over here? This is such a cool little camera. Look at this. This looks like cock and fucking balls. This is cock and balls. This needs to go. So, now, again, do you think I'm going to test every single little part of the circuit when those pieces cost me virtually nothing? Nah. We're going to play the game of we're not going to go to Mouser.com. I'm not a Mouser.com kind of guy when it comes to fixing motherboards. I don't mean that I don't like them. I mean I'm not a Mouser.com type of guy in terms of I am not going to tell you that what you need to do is go to Mouser.com and order each one of these individual components without knowing which one's actually bad. I'm much more the type of guy that'd rather just buy a bunch of dead boards that were not water damaged, that have a hole through them, on Alibaba or some supplier. Don't ask me who, because this shit literally changes every single time I buy a set of boards. And what I'm going to do is I'm going to just replace all the things that I think are bad in that area by using my eyes. So keep in mind, I have taken out my multimeter so far to look and see what the value of PPV Core SO GPU is, and I saw that that was not what it was supposed to be. Now what I'm going to do is I'm not using my multimeter to test each individual capacitor, each individual diode. Now I'm switching over to a more efficient method of working, which is using my eyes to test what is bad. So my eyes, without probing the component, are telling me that I should probably replace this, that just because it's right next to it for the hell of it, and this. And we're also going to replace this chip. Now, if anything else is bad, we're going to go from there. Then we're going to start measuring. Then we're going to start using our brain again. But right now, I've switched from using my brain to just simply using my eyes, because I want to be efficient. Efficiency is very important. In doing this, as I said, I don't want to spend more than 20 minutes on a motherboard. It is very easy to spend inordinate amounts of time on these boards. So, you know, running down rabbit holes and chasing problems that you're probably never going to solve. And this is all about efficiency. So there are times when I really, really want to know the exact problem, and then there are times where I just don't care. And this is one of those times where I just don't care. I want to test my theory. If you really want to know if one of these chips is bad, by the way, what you can do, there's no like official check. You can simply use diode mode measurements or measure resistance to ground on certain pins and compare it to a known working board. But here's the thing. You know, when I get that whole board for like 15 or 20 bucks, the time that it's worth, like it actually costs more in time for me to do that than it does for me to simply replace it. The time is actually more valuable than the chip, which is why we're going to take that stuff off. And one of the other things I do is, while it's still hot, I actually solder it onto my desk. The reason for that is to remember orientation. Don't assume that your brain will remember orientation. I'm telling you, that is a bad idea. Don't assume that you will remember which way the chip goes. I would buy a desk that you really don't care about fucking up. I have an IKEA desk here, and I don't care if I fuck it up. I'm not passing this furniture on to my children. This is here to be used to fix boards. It's purpose-built, purpose-made for that. It's weird that I say purpose-built for that, because at IKEA, they sure as hell didn't intend for me to fix motherboards on their table. But what I mean is that I purposely purchased it for that. I'm not going to be mad if there's marks on it. Again, what's more important to me is that I know the orientation of my chipsets on the motherboard. So I'm going to do is I'm just going to fill up those pads. As you can see, I screwed up those two resistors. That should not be a surprise to any of you that regularly watch the soldering that I do on this channel. Right, now that should not be a surprise to you either. What I really should do, if I wanted to set a good example, was wick all of the lead-free solder away before applying leaded. And you know what? I might just do that, because this is supposed to be a video where I show you how to use your brain. So let's just go ahead and do that, since it's the right thing to do. Let's wick away all the lead-free solder. Soda. Every time I say solder without an L, a bunch of people cry. So I kind of find fun in that now. Right. Use some wick. I almost disobeyed one of the cardinal rules of wicking, which is do not remove the soldering iron before removing the wick. Whoops. Alright. Alright, now what I'm going to do here is clean it a little bit. I'm going to make sure to make it nice and clean. And not emphasizing the S's is really going to take exercise. That's one of the things you learn from like working at a recording studio is you don't spend all this time on the plugins and the gear and the equipment and the angle of the microphone and where the microphone is. Like, is the sound that you're capturing actually a good sound? Like, walk into the room and listen to it. And that's one of the things I noticed with this channel. As soon as I decided to actually give a crap about audio quality, which I can't really say that I actually have chosen to give a crap about audio quality, is that I would listen to how I was speaking. I'd really pay attention to it. And there's a lot of S's in what I say. A lot of S's. So instead of focusing on fixing the audio, I should focus on fixing my speaking. Really. That's what that is. That's what that is. So, okay, we're going to put some flux there, get those components knocked back into place. This microscope camera looks really good. And that's a nice image. I'm going to start auto-adjusting more often. It really makes these look better. Okay, we'll flow that into place a little later. Okay. I should use the other tip. The other tip is better at tinning the pins of a QFN. Alright, let's get this tip plugged back in. Beep more, Hacko. Beep more. One of the things to note, the finer your tip gets, the lower the actual temperature of it is versus what your station says. So when I have the larger tip, if I set it to 700, it's going to be around 700. When I have the smaller tip, I set it to 840 because I know that when I have that thing set to 700 and I got a smaller tip, that the fine point of that is not actually that temperature. So when you see all these people that are soldering outside of, whatever specification it is that I never check and never care about, that people are always telling me I should care about, one of the things to realize is that most of the people who are actually doing that work are doing it with really large components. So they don't have to worry about, they don't have to worry about this stuff the same way that we do. And most of them live in a different world, and they're not really interested in helping us do the type of work that we do, which is why I'm not really interested in caring. Alright, we're going to replace some of those components that are around it. First, I think it may be better to put the QFN on. What did I almost forget? A little bit of solder on the center pad. Just a little bit. Okay, I'm trying to be lazy and I shouldn't be doing that. There we go. Clean it a little. Throw the alcohol away. Okay, the alcohol is blown away. Apply some flux. If I didn't use too much flux, I wouldn't be me. I'm a flux abuser. And if I didn't put too much solder on the center pad, I wouldn't be me. Oh no, a solder blob! Who cares? Heat up the iron. But you can't just heat it up without having flux in there, because without flux the solder will not flow. So I added that flux for that reason. Yeah, a pretty well aligned chip. So now I know that the amount of solder on the center pad is perfect the amount, because any excess was simply just escorted out. Heating it to make sure that it sits in a place where it's supposed to be. It is beautiful. Now time to replace the nasty, nasty components. If it works, it works. If it doesn't work, then what I'm going to do is I'm going to go back and see what those components are, see what the nasty parts were for, what they do, and do some detective work. And for now, I'm not in brain mode. Brain mode was figuring out that there was no GPU V-core. Now I'm just in monkey mode. Me see nasty thing, me replace nasty thing. I switch back and forth between brain mode and monkey mode so that I can save my brain. And I need my brain to figure out complex issues. I don't need my brain for this shit. I do want to know what that little green component is for. That thing looks cool. It looks like it wants to jump off the board. It wants to make a break for it. Again, there's only so many times you could heat up the solder that you put there before the flux flows out of it, and you just get kludgy piles of junk. See how the component just jumped into place when there was flux on it? That's why I do that. I should try capacitor shorting like that. Alright, now for that other component, let's just see what the GPU area looks like on this board. Because I don't want to be surprised. And I can't say there's anything here that makes me too unhappy. A little dusty. But otherwise fine. So what I'm going to do now is I'm going to plug my screen. And I'm not even going to measure and see if I have GPU V-core. Again, what I like There's no reason to not jump ahead of myself. I'm not going to lose anything but the few seconds it takes to plug in the LCD. So we're going to plug in the LCD screen. Plug in my DCN board. I don't know why I unplugged the DCN board to just replace something for... No, I didn't. I just wasn't looking. I'm still in monkey mode, apparently. Make sure I don't reball anything. Okay. Now I'm going to put the multimeter in voltage mode. My GPU V-core is 0.897. 0.897 is closer to 1 volt than what I was before. Also keep in mind that it may go up and down based on what the thing's actually doing. Fortunately, I still don't have that thing on my screen, but I did see it try to activate. I saw something went on there. And I am getting 3 volts at my screen. But on backlight, I have 0 volt, nothing. Let's see if I have what I need on the actual picture of the screen. So one of the things I have here is I have a really cheap LED light that I don't know where I got this thing. It was an extra for a microscope. It comes in really handy for these do I have backlight, do I not have backlight situations. So what I do is I do this, and I can illuminate the screen. So I didn't see anything on the screen just yet, but I did see the screen like kind of pop on and activate, which is progress. That's a good thing. Alrighty, so what I'm going to do here is I'm going to turn this thing on and see if I get anything on the screen with my microscope light. So I put this back there, and if I see a question mark folder, I'll know that my problem now is I'm not going to be fighting no image, I'm going to be fighting no backlight. So I'm going to wait a second and see that I get that question mark. And I may not be able to show you because this microscope light is not really strong enough to illuminate everything the way I want it to. But it's good enough that you can clearly see if there's a picture on the screen. It just takes a while to get to the point of having a question mark. Yeah, so as you can see here, I don't know if you're going to be able to see this. See that? That's a blinking question mark folder, which means that, again, this whole idea of reballing shit without using your brain, it just needs to go away. Again, well, one of the things that I keep telling people, that everybody says, I don't have the expensive tools to do what you do, I don't have what I need to do what you do, is, how often am I using a BGA tool to solve a motherboard problem? Almost never. Truthfully, I am not. I use that machine for about 1% of my repairs. And that machine costs like $7,000 something. If I could go back in time, I probably wouldn't have bought the damn thing. But, what can you do? Really, it would have just been cheaper for me to simply outsource BGA rework-related repairs to somebody who does them and just not do them myself because it just doesn't make sense. Again, all the things that you would make money doing BGA rework on, they're just done. Like, the DV9000 era of printing money, with GPUs is done. The whole era of making silly amounts of money off of Apple boards doing GPUs is done. That, you may not like it. It is what it is. All right. So what I get a 0.515 measurement when I do diode mode to ground in the backlight circuit. So let's go over to the backlight circuit now because that's the next piece that we're going to have to tackle over here. So let's go over to the backlight chip U9701. All right. So what I do here, when I want to get an idea of what's going on in a circuit, I measure resistance to ground or diode mode to ground. Remember in my video where I'm discussing what ground is? What I'm talking about is ground. You need ground in order to have a circuit actually do anything. Like the electricity sitting up here is not going to do anything if it doesn't see ground, which it wants on the other side. So what you do is you put your circuit and all the crap that you want to have happen in between the ground and and the power. So the resistance that you have to ground is going to be different if something is malfunctioning. For example, let's say let's go over something like the screen connector. All right, so this is the LCD connector, right? So let's say the casing of the LCD connector is shorting to pins 38, 39, and 40. I'm going to have a 0 voltage drop to ground because there's a short in the connector where PPV out SO backlight is shorting to ground, or it's shorting to the housing of the connector. Let's say my LP8550 chip is bad, so let's go back to U9701. Let's say this chip is bad. Instead of me having a 0.5 voltage drop to ground or whatever in diode mode, what I'm going to have is I'm going to have a 0 or a 0.2 or a 0.3. This way you can kind of think and you can really get to realize what is wrong with your circuit. So every time I figure out something that's wrong with this, what I do is I actually write down in an Excel document exactly what it is that was wrong with that circuit, and then before I fix it, I write down the diode mode measurement that I got, or the resistance to ground at that point in the circuit. So next time that I have an issue with that circuit, I don't have to go nuts going through everything again. Again, I'm saving my brain and saving my time. I make my measurement, I refer to my Excel sheet, and then I have a little bit of a shortcut as to where to start looking. So with this circuit, I'm supposed to get 0.519 to 0.546 on working boards. Here I am getting on the multimeter when I put the red probe on ground and the black probe on backlight output. Right now I have 0.529, which means that there's no path to ground that shouldn't be there, and for the most part from here to ground is good. So I know that my feedback line is probably good. I know that this is not shorting to ground. I know that these caps are not shorted to ground. I know that my LCD connector is not shorted to ground. So now what I'm going to be looking for are things that I can't measure for. For example, like all the way over here on this end is this voltage divider that tells the 12-volt signal opening here to go to backlight enable to make 3 volts for the enable pin there. Do I have a PWM signal? Is this transistor good? Is it opening? Is my fuse good? All those things, those are things that I'm going to now start troubleshooting, and I'm going to talk to you about what I'm measuring and what I'm doing as I do it to try to get backlight. As always, if you're using this circuit, one of the things that you need to do is you need to have the LCD connected. You cannot test the backlight circuit without the LCD connected, because this over here, LCD backlight enable, if it does not detect a screen, this signal will not present. If this signal does not present, this transistor will not open, and you will not have a backlight circuit. So the first thing that I'm going to do over here is I'm going to check the fuse. So F9700 up here, let's see what voltage I get on both sides of that fuse. So I'm going to measure, and what I get on, let's see, so on one side of the fuse I get 12.5. Other side of the fuse I get 0. So that means that, wait, I just got something. The fuse on this board is actually covered in flux, and the other side of the fuse I get 12. Okay, so now what we're going to do is we're going to check Q9706. So I don't know where Q9706 is on this board, which means that I have to find it using the board view software. Again, a lot of you people think that I'm a genius because I know where all the components are. I am not psychic. This program does it for me. Without this program to do it for me, I would be screwed and clueless and have no idea what the hell I'm doing. If you think I know where components are on the board because I'm psychic and I just learned it in college or something, then no. That's not how this works. This program tells me where everything is. This program does not fix the boards for me, but it does tell me where things are so that I can at least start using my brain and figure out where things are. Don't ask me where to get this software. If I told you, I would be in even more violation of the law than I am by simply having this channel to begin with. All right, so let's see. Do I have power on the output of this thing? I do. So I have power on the output of the circuit. So what I have over here, I have 12, 12, 12, and then 12. So now I want to look at the next part. Over here, L9701. Is the power making its way to L9701? It is. And on backlight output, I actually have 12. So the power is there, it's simply not boosting. So now we check backlight enable and backlight PWM. We're going to turn the board around. Those are components that I actually have the locations of kind of memorized, so I thought I had them memorized until I went to measure and realized I didn't. So let's see. So for backlight enable. So again, when these signals are present, it's going to open this transistor, which is going to allow the 12 volts through the backlight circuit. This needs 3 volts on the enable pin in order to operate. If I send 12 volts to that enable pin, nasty things will happen. So what do? They simply take from this backlight rail. So once these signals are present, it's telling the backlight to turn on. So let's just take that 12 volts and turn it into 3 for that enable pin using R9731 and R9715. Let's go on the board view here and check R9731, R9715, see what they look like, see where they are. Okay, they're over there. Of course, it's opened in the exact opposite way of how I have the board in the fucking desk. The board view program does that. Even though this program is from 1995, it does have drivers for HDMI capture cards and artificial intelligence that will always look through my camera to see the exact way it's open on the desk so that it can open it opposite in the fucking software. And these people at Landrex, they know their shit. So I have 3 volts over there. I do have 3 volts over there. Now let's look at the backlight PWM signal. If I don't have a pulse, I won't get any boosting. So over here we have backlight PWM. And again, the way I know this, you can either Google for the data sheet for an LP8550, or if you don't want to Google for the data sheet, you can measure a working board and then compare the working board to your non-working board. If you don't want to do any of that, you're probably a lazy fuck and you're never going to fix a motherboard. I would highly suggest just having the basic motivation to learn before you start doing this. Because one of the things you'll find is that most of the people that give away most of the people that know this stuff are much less inclined to give away the information for free than I am. Hell, one of the things you'll find is even I'm not that inclined to give it away for free when you ask a silly question or you're not thinking. Okay. So my backlight PWM signal is present. So all of that is present. I have a backlight PWM signal. I have that, but I only have 12 volts on output. This is where it gets to be a pain in the dick. All right. Bleh. Okay, let's see. This already had the LCD connector replaced by somebody. So let's see if there's anything funny going on there. Let's also look in the LP8550 area of the board. Okay. I don't remember if that was me screwing with it or somebody else. I'm pretty sure somebody else because I know that I would check for no video before replacing a backlight fuse. What makes me sad is I know that what you see right here is not what you're going to see after YouTube takes my video and skullfucks it. But that looks really, really good. I mean... Alright, so right over here I see something I don't really like. See that red thing? That makes me sad. So let's just pick this chip up. Further inspection. Turn my heat up to where it should be. There's no real reason to look at me. Here we go. Pay attention. Miss. Yeah. Right. I disobeyed my own rule and forgot orientation. And yeah, good luck reading the orientation off of that piece of crap. Oh. These boards are baked. Okay, I found one that shows me the proper orientation, which is... Push down. Don't be shy with the pushing down. Okay. Just don't do what I just did. When you're done, of course. Alright. Slowly move in. I'm patient. I got all day for this. Those backlight enable resistors look nasty. Another thing, I know that they're actually working. I have knowledge that they're working from measuring the voltage at that point. I still don't like them. Okay, I just saw the chip go into place. Now I make it dance. Dance, mofo. Okay, now I know that it's dry. You see how I made the chip go dance? I yelled dance, mofo, and it danced. Alright. Of course, that board has backlight enable resistors stolen. That one has backlight enable resistors that look even worse than this set. Ick. Is that even soldered to the board? I get more and more boards that have been pre-fucked since this YouTube channel. I can't complain because, I mean, I literally asked for it. I mean, by putting this stuff up here, I kind of asked for it. Like, I asked for the world to start fixing boards again, and what happens when people do things that they don't know how to do? They fuck them up. That's gross. Really gross. But let's just see what happens before I go any further. I wish they made a remote control for this air filter. I would settle for a pedal because it's really loud. You can use it at the lower settings, but at the lower settings it kind of defeats the purpose of having an air filter. I would love a pedal that goes under the desk. Maybe I'm just being a spoiled customer. That's one of the worst insults that you can give around here. Like when we go back and forth at the store, I mean, Steve will look at me and go, "You're being a customer." I think it's similar in the IT world, like the help desk world. One of the worst insults you can give, one of the worst insults a help desk person or a systems administration person could ever give to a human being is saying you're being a user. I mean, that's It's one of the worst. I forgot what I was talking about. Let's turn this on and hope that it works for my blind monkey work. Oh, no backlight. All right, we're gonna. I'm getting humbled by the easiest problem there is to fix. Now this is embarrassing. What the fuck, man? Okay, what voltage do I have on LCD backlight output? At the LCD connector, I have okay, this makes sense now. So I have 12 volts on backlight output. This is so stupid. I'm a fucking idiot. Why do I assume anything is good on boards that other people fucked with? Why? What the fuck is wrong with me? Okay. U9701. Here we go. So on backlight output over here, I have 12 volts, right? And on J9000, the LCD connector itself, over here, I have 0.06. Sometimes 2 volts, sometimes 4 volts, sometimes 0 volts. Either way, no. So what we're going to do now is we're going to run a wire to that LCD connector. Mess. I'm guessing maybe the pads were burned or something. I don't know. I don't care. And to be 100% honest with you, with boards that were fucked with before I got them, I don't quite put in the care and the effort that I would on boards that are not. Like, I'll still solve the problem. Don't get it twisted. I'll still solve whatever it is that's wrong with the motherboard. I will solve it, but caring about like taking your LCD connector and looking into your LCD connector and all that crap, no. You chose to fuck with it before you sent it here, so I will choose to put it back together whatever way I see fit. Alrighty, so we're going to run a magnet wire from here to there. Because like I could redo the connector and then see if it works right after redoing the connector and then check all the V's and the pads and the board and all that stuff. But again, somebody chose to go out of my way to make my life just a little bit harder. So why am I going to go out of my way to avoid you getting a wire on your board? Doesn't make any sense. Really doesn't. You fucked with it, you live with it. And that's the least that I'd be able to expect if I were doing this to other people. Like if I mess up a board and I give up on my own and I get it back and it has wires crawling all across it, you know, I kind of earned it. Alrighty. Okay. Let's strip them. The other side is fully 100% stripped. And I'm using the wrong tip for what I'm trying to do. This is so very much so the wrong tip. Where's my curved tip? Give me that tip. Give me that curved tip. Why'd you take away my red? I guess it thinks that that's fine, so. Who am I to fight with the automatic color balance of the microscope camera? Ready? Okay, and now we make a trip to the other side of the board. I should cut that shorter. We need more red. This looks like Winterfell from Game of Thrones. I like some red. Give me some red. All right. What the fuck did you do, mofo? You know nobody's supposed to suck at soldering connectors worse than me. You're taking my reputation. Okay, that's bullshit. Why is that bullshit? Because it's sticking up from the board. I just put it there so I have it there as a placeholder. You want it to be sitting perfectly flat with the board. Anything other than flat with the board is BS. Just so you know. Oh, you couldn't see that. Oh well. Okay. Let's turn this mofo on. See if this works. I didn't check that before being a monkey and replacing the LED driver. See, even I do monkey stuff sometimes, but I try to minimize the monkey things that I do. And when I do monkey things, I actually put them on camera instead of saying that I'm perfect so that you can learn from them not to do them. I don't mind keeping screw-ups in a video. That's the whole point, is to learn. Learning what not to do is as important, if not more important, than learning what to do. By process of elimination, if you know what not to do, eventually you will know what to do as well. Ladies and gentlemen, we're done. Well, I mean, I should run ASD and firmware on it to make sure it actually works, since the GPU had issues with vCore, but for the most part, again, I'm not doing all that on camera is going to make these videos really unnecessarily long. Honestly, with these videos, I know people aren't going to believe this, but if this winds up not passing GPU test and firmware and ASD, I don't wind up uploading them because I just feel like it's wrong. But yeah, question mark? Oh, there is no question mark here. When you get to the question mark folder, you'll get to see it. I'll make sure you see it. See that? It means we're done. So let's go over a couple of things that we learned today. Firstly is that the thing that I talked about not doing in the last video of, wanting a chip to be bad or wanting a component to be bad when it's actually a trace or a via. I actually didn't listen to my own damn advice. That's the advice that I give myself every single fucking day. And it didn't work. And one of the things that I actually remember now is that I was getting 12 volts at that LCD connector before, but then I got 1, and then I got 12 volts again. So I actually didn't think that the problem was with the voltage getting there because it was intermittent. I just thought that maybe I wasn't poking my meter through the flux. What I should have done there is I really should have poked and checked that LCD connector again, and I should have kept it there for about a full minute and looked at my multimeter. I was being impatient. I was being petulant. I just wanted to get it done with as quick as possible. So I wasted a chip. I wasted $5. I wasted my time, and I did something really stupid. So if you see that something's messed up and then it just clicks to where you think it's supposed to be again, just keep your meter there for a second, and don't make the mistake that I just made on camera. Secondly, again, with this whole GPU replacing shit and this GPU reballing and this reflowing and all this crap on all these internet forums and all these YouTube videos, stop doing that. Stop heating shit up without using your brain. Again, if your GPU is getting 0.01 volts, it doesn't matter if you're using a new GPU, it doesn't matter if you're using lead-free balls, it doesn't matter if you're using leaded balls, it doesn't matter if you're using Peter North's balls, it's not going to work if it's getting 0.01 volts. Check your circuit before you start being a monkey and heating shit up in an oven. And again, check your circuit before you start being an idiot and fucking replacing LED drivers that actually work when the problem is circuit related. Again, everybody wants it to be a chip problem. It's not always a chip problem, it's a circuit problem, and people don't like that because circuit problems mean that you have to think and then you have to work a little bit at it. And I just noticed I had a bunch of flux on my hand, so that's what I'm cleaning off here. But yeah, this is an 820-3330 board. This board is worth maybe, I don't know, like $600 maybe at the time that I'm posting this video, like if it works. It was worthless before, and now it's worth something, and it didn't take much time, it didn't take much effort, didn't take much thinking. All you got to do is just follow through the circuit and just use your brain. Again, what I'm trying to get accomplished with this series is showing you that you don't have to be a genius to do this. I'm tired of this implication you have to be a genius to do this. You want to be the people that are setting up the security system top to bottom for the new World Trade Towers, then, you probably got to be smarter than I am. But to do this, to make a a broken $600 basic laptop motherboard work again, you don't have to be that intelligent.